Today's lesson is going to be on sequences of transformations. These are the types of problems that I've been telling you are coming up where they're going to combine 2 or 3 different transformations in just one question. So here's our first example. In this example, they're telling us to draw the image of triangle ABC after the given combination of transformations. And right here, they're telling us what are the transformations that they want us to do. There's 2 of them. First, they want us to do a reflection over line L, and then a translation along vector V. So let's look at those one at a time. First, as you can see in this picture, here's our starting point. Here's triangle ABC. Now, if you go over to this picture, it shows us that they're first doing the reflection over line L to get triangle A prime, B prime, C prime. And I'm not going to go over the details for this particular example of how to get those exact points because you're not going to have to do that for this type of example. There are other examples where you will have to do that, and I'll show you in a moment. But for this one, I just want you to see that they're reflecting it over line L. And then after you do the reflection, you have to do a translation along vector V. We haven't seen that for a few classes. It was a few classes ago that we went over that, so just a quick refresher. Here's vector V. Vector V is telling us to move the shape from the bottom left to the top right. So it's telling us, if we look at the length of this line, it's telling us that we have to move the shape 1 unit up. 1 unit up and 1, 2, 3, 4 units to the right. 1 unit up and 4 units to the right. So that means that after we do our reflection of our figure over line L, which they did here, we're going to take each one of these 3 points and move each one of them 1 unit up and 1, 2, 3, 4 to the right. And when you put that new point, since this is our second transformation, I'm going to put 2 apostrophes. And I'm not sure what the correct term is to refer to that, but since this is C prime, I'll refer to this for now as C double prime, even though I'm not sure that's the correct way to say it, but let's just call it C double prime. All right, so B prime, I'm going to move it up 1, and then 1, 2, 3, 4 to the right to get B double prime. And then A prime up 1, and 1, 2, 3, 4 to the right to get A double prime. Okay, and that would be it. I would be done with my question. And as you can see, here's the final answer. Okay, let's look at another example. Okay, on this one, they want us to do a 180-degree rotation around point P, then a translation along vector V, then a reflection across line L. So there's 3 transformations that we have to do. So let's do one at a time. Now on this one, I am going to go over how to get the exact coordinates when you do a 180-degree rotation. All right, so let me point out something. Please make sure you're paying attention to this. When you look at this picture, we do not have a y-axis here. All we have is this x-axis, or this line L. It's not even the x-axis, it's line L. So we do not have an x or a y-axis. However, one way I could do the rotation, the 180-degree rotation, and make sure I get it right is I can pretend that that this point right here is 0, 0. In other words, pretend that the y-axis is right here. All right, look at the line that I'm drawing or hovering over. Pretend that this is the y-axis and that this line in the middle here, line L, is the x-axis. All right, so we'll treat this point as 0, 0. And that way I could apply my rules of how to do a 180 rotation to rotate correctly, exactly, this triangle right here. Okay, so let me show you what I mean. To do a 180-degree rotation, the rule states that you got to get the x and y coordinates and change them to the opposite sign. If you don't remember, the way I told you to remember is that when you do a 360 rotation, the coordinates stay the same, and I wrote the word duh after it. 180 is related to that one because it's almost the same thing, except you got to change the coordinates to their opposite sign. Okay? Either way, that is the rule when you do a 180-degree rotation. All right, so now what I'm going to do is for A, B, and C, I'm going to write the coordinates of the pre-image. All right, the coordinates of the points that are right there. Okay, so point A, if we treat this point right here as 0, 0, point A would be located at 1, -2. Point B would be located at -1, -3. And point C would be located at -1, 0. Now when I apply this rule, all right, the coordinates would change to A prime would now be at -1, +2. Okay, B prime would now be at +1, +3. And C prime would now be at +1, 0. So let me graph that real quick. A prime, -1, +2. Okay, B prime would be at +1, +3. And C prime would be at 1, 0. Now, if the question is multiple choice and you have to choose between 4 pictures, you could probably do that just by looking at the pictures. However, I'm going over the details of how to get the exact coordinates just in case you have to do that. You should be aware of how to do that. Anyways, that completes my first transformation, which was this one. Now I'm going to do the next one, which is a translation along vector V. So let me change my pen color to blue so it'll help us keep track of what we're doing. All right, so here's vector V. Vector V is telling me that they wanted me to move the figure 1 unit up and 1, 2, 3, 4, 5 units to the right. Again, vector V tells us to move the figure 1 unit up and 5 to the right. So I'm going to do that to all 3 of my points. So let's start with B prime. 1 unit up and 1, 2, 3, 4, 5 units to the right. And I'm going to write B with 2 apostrophes because that's my second transformation. And I'll call it B double prime. I'm pretty sure that's the right term, but I'm not 100% positive. A prime, let's do the same thing. 1 unit up and 5 to the right. And C prime, same thing, 1 unit up and 1, 2, 3, 4, 5 to the right, and I'll put C double prime. Whoops. All right, so I got one more transformation left to do. Let me change my pen color. All right, which is a reflection across line L. Okay, now on our first example, they were doing a reflection across line L, but line L was slanted. And I told you that you're not going to have to do that and get the specific points. However, if they give you a line that's perfectly horizontal or vertical, yeah, that you will have to know how to do because that's very simple. That's common sense. All right, so look, if I have to do a reflection over line L, every one of these points has to be the same distance away from line L, but on the opposite side. So for example, C double prime is 1 unit above line L. So when I reflect it, it's got to be 1 unit below. And I'm going to write C triple prime with 3 apostrophes. B double prime is 1, 2, 3, 4 units above line L. So if I reflect it, let me make sure I counted that right. 1, 2, 3, 4. Yeah. If I reflect it, it's got to be 1, 2, 3, 4 units below. And again, B triple prime. And A double prime is 1, 2, 3 units above. So if I reflect it, it's got to be 3 units below. And now I'm done. Okay, so again, if on your homework assignment or on an exam you get this and it's multiple choice, you could probably do it without going so much into detail. As long as you have a good idea of what the 180-degree rotation looks like. And the way you could do that without going into so much detail like I did, you should know how to do this as well, but I'm just giving you another way. Let me change my pen color one more time to green. Okay, another way you could have looked at the 180-degree rotation, because that was probably the one that's most likely to create an error if you're not sure how to do that, is try to see what's the easiest line you could focus on. All right, in my opinion, the easiest line to focus on would be this line right here because it's perfectly vertical. All right, so if I rotate that line 90 degrees in either direction, all right, let's say 90 degrees counterclockwise, which is like this. All right, then that green line would go like that, would have to be like that. If I rotate it 90 degrees again for a total of 180, the green line would be like that with the C on the bottom and the B on the top. And as you can see right here, that's what I have. The C prime is on the bottom and the B prime is at the top. All right, so that's a way that for rotations, a lot of times you can get away with just looking at that to answer the question if it's multiple choice, right? If you gotta specifically graph it yourself, then that's different. You do gotta know how to use the rule. Let's look at another example here. And there's the answer from the book, which will be uploaded with the PowerPoint to Microsoft Teams webpage. Okay, so right here I got two problems. Let me do number 7 first. It says draw the image of the triangle after the given combination of transformations. So in number 7, you have two transformations that you have to do. First, you got to do a reflection across L, and then a 90 degree rotation around point P. Okay, so let's do one thing at a time. First of all, let me do the reflection across L. For that one, I could just do it by looking, all right? Again, when you do a reflection across a vertical or horizontal line, across any line, but when you have a horizontal or vertical line, all you got to do is look and make sure that the points are the same distance away, but on the opposite side. So if B is 1 unit to the left of this line, B prime would have to be 1 unit to the right if you're reflecting over that line. If A is 1, 2, 3 units to the left of this line, A prime would have to be 3 units to the right. And if C is 1 unit to the left, C prime would be 1 unit to the right. So there is my first transformation, a reflection across L. Okay, now the next one, okay, I am going to write out the coordinates, okay, in order to get it exactly correct. And look how I'm going to do it. I'm going to use the same technique where I'm going to pretend, since they want us to rotate around point P, this I recommend that you pay attention, right? They want us to rotate around point P. Okay, if I treat point P as if it were 0, 0, I could apply the rules of rotation to these coordinates. Even though I don't have an x and a y axis here, I'm going to pretend like P is 0, 0. So look, the rule for a 90 degree rotation is I'm going to get the x and the y coordinates. Okay, now the way I recommended that you memorize them is that 90 degrees goes with the 270 degree rotation to learn them together. Okay, in both of them, the y and the x and the y switch places and become y and x. And I said that 90 goes before 270, so in the 91, it's the first one that you got to change to the opposite sign. If you don't remember any of that, it's worth learning. However, the point of the story is that that's the rule for a 90 degree rotation, and that's what I'm going to use to get the new coordinates for the final transformation that I have to do. Okay, so let me write the coordinates of A prime, B prime, and C prime right here. So A prime, okay, look, if I treat this as 0, 0, that means that this is my x-axis here. So the x-coordinate will be 1, 2, 3, 4, 5. And the y-coordinate would line up, if this is the y-axis, this line right here would line up with positive 1. For B prime, if anybody's lost, again, I'm treating this point, since I'm rotating around point P, I'm going to treat point P like it's 0, 0. If this is 0, 0, that means this line right here is the x-axis. I'm just pretending. It's not the x-axis. We're just pretending so that we could use that rule. And this line right here is the y-axis. Okay? So B prime, the coordinates, if this is 0, 0, B prime would be at 1, 2, 3 would be the x-coordinate. And if I look over here, 1, 2, 3, 4 would be the y coordinate. And for C prime, okay, so the x coordinate would be positive 3, and the y coordinate would be positive 1. Okay, now I'm just going to apply this rule for a 90-degree rotation. So A double prime would have to be at -1, positive 5. I'm just switching the places of x and the y, and the y, I'm changing it to the opposite sign, so 1 became -1. B double prime, I switch their places, and the y becomes the opposite sign. And C double prime, I switch their places, and the y becomes the opposite sign. Now let me graph those points, and I'll be done. Let me change the color of my pen to blue. Okay, so A double prime, if you pretend that this is 0, 0, would be at -1, positive 5. 1, 2, 3, 4, 5. B double prime would be at -4, positive 3. 1, 2, 3, 4. 1, 2, 3. And C double prime would be at -1, positive 3. Okay, my triangle didn't come out that beautiful, but as you can see, this is the final result after a reflection over line L and a 90-degree rotation around point P. Okay, as you can see, if you had to just pick a picture with the reflection over line L and then the 90-degree rotation, you could probably just pick the right picture without doing all this work. However, if you actually had to manually graph those triangles, you would need the exact coordinates, because the odds of you perfectly graphing this red triangle where the blue one is are not good. Even me. All right. The only way to know for sure where the points are to come up with the coordinates. Again, most of the questions like this though is just going to be pick the right picture. So don't panic if you think this is a lot of work. As long as you have a general idea of how it works, you should be able to see which is the right answer. And again, just to say something I said previously, the reflection over line L is obvious, but now the 90-degree rotation, let's pick a side that's easy to focus on, and you could see how you could figure out, if you have multiple choice, which is the right answer. Okay, look at this line right here. Always, I think the easiest one to look at is if you have a horizontal line, and if that's not available, a vertical line would be the second best choice. But if you have a horizontal line, look at C prime, A prime. It's right here. We know that if I rotate that line 90 degrees counterclockwise to the left, that line has got to end up like this line. That would be a 90-degree rotation. So if you look right there, C double prime and A double prime are right there. Okay, so that, just with realizing that, and also realizing that this side would have to be at the bottom. Okay, just with realizing that, most of the time you could just pick out the right answer by realizing that. So it's not as complicated as it may seem. Let's do number 8. Okay, number 8. They want us to first do a translation along vector V, then 180-degree rotation around point P, then a translation along vector U. All right, so let's start off with the translation along vector V. Okay, so vector V, if you look at it, it's telling us to move the figure 1 unit up and 2 units to the right. 1 unit up and 2 units to the right. So let me do that to every single coordinate, G, E, and F. 1 unit up and 2 to the right would put G prime right here. 1 unit up and 2 to the right would put E prime right here. And 1 unit up and 2 to the right would put F prime right here. Okay, next one is a 180-degree rotation around point P. Okay, here's point P. I'm going to do the same technique I used last time. I'm going to think about it as if it's 0, 0, and that'll allow me to use the rules. So a 180-degree rotation, the rule is x, y is going to become -x, -y. All right. Okay, so first I'm going to write the coordinates for, let me keep it in alphabetical order, E prime, F prime, G prime. So E prime is going to be, E prime is right here. If that's 0, comma 0, it would be -1, +3. F prime, if that's 0, comma 0, it will be +1, +1. And G prime, where are we? It's right here. Okay, so if that's 0, comma 0, it will be -2, +2. So when I apply this rule, E double prime is now going to be, I'm just going to change, that's telling me just change their signs. So it'll be +1, -3. F double prime is going to be at -1, -1. And G double prime is going to be at +2, -2. Okay, so now let me graph that using the color blue. Almost done. So E double prime, if this is the origin 0, comma 0, that means E double prime is at +1, -3, which is over here. F double prime would be at -1, -1. And G double prime would be at +2, -2. Connect the dots. Okay, and the last step is a translation along vector u. All right, so vector u is telling us to just move the figure 1, 2, 3 units to the left. 3 units to the left. We're not moving it up or down, just horizontally to the left. 3 units. So if I move all 3 of these points 3 units to the left, F triple prime would be right here. G triple prime would be 1, 2, 3 right here. And E triple prime would be 1, 2, 3. And that will be my final answer. So again, if it's multiple choice, you should be able to look at it and figure this out without having to go into all this detail. Okay. First is the translation along vector v, and then the 180-degree rotation. If you first of all, whenever you rotate 180, it doesn't matter whether you go clockwise or counterclockwise. It ends up in the same spot. Okay. Let me see what other color I could use here. Okay. So if you focus on this shape, you could look at the triangle as like this is the point. The point. Let's say point F is like the pointy side or the nose of the triangle. So if I rotate it 90 degrees, let's go, since there's a mess over here, let's go clockwise. Okay, if I rotate it 90 degrees, it's going to be something like, something like that, and then 90 degrees again, something like that, all right? So I'm just improvising. It didn't come out perfect, but I'm just giving you an idea of how you could visualize how it's moving to find the right answer, especially if it's multiple choice, to minimize the amount of work you have to do. But again, you should know how to get the exact coordinates in case you need to do it that way as well. And those are the answers. They'll be on the Microsoft Teams webpage. Okay, let's look at this. It's basically the same thing. They're just writing it slightly different. Okay, so in the first one, they want us to reflect triangle ABC over the y-axis and then translate it by this vector. That's easy, but we haven't seen it in a while, so let me just do that example here in case you need it for the homework. So the first part is very simple. Translate over the y-axis. So A prime will be right here. C prime will be, it's 2 units to the left, so I got to put it 2 units to the right. And B is 1, 2, 3 units to the left, so B prime has to be 3 units to the right. Okay, now the next step is translate by this vector. Okay, now in case you forgot, I know it's a vector because on the side it has those symbols. So that tells me that it's a vector. The +2 means you got to add 2 to all the x coordinates. Or a simpler way of thinking about it, that just means you're going to move every one of these points 2 units to the right. Because remember, the x coordinate controls movement right and left. So if I add a number to the x-coordinate, it's going to move it to the right that number of times. If I subtract the number to the x-coordinate, it's going to move it to the left that number of times. And this number over here, we do it to the y-coordinate. Since you're subtracting 3, that means it's going to move the figure 3 units down. 3 units down. If I would have been adding a number, it would have moved it up. Okay, so let's just do it all together. So this is telling us to take this figure, this triangle, and move it 2 units to the right and 3 units down. 2 to the right and 3 down. So I'm just going to do that to every point. A prime is going to go 1, 2, 1, 2, 3. And that's going to be A double prime. B double, wait, this should be just one, sorry about that, just one apostrophe here, that's B prime. So B prime would be 2 to the right and 1, 2, 3 down right here. And C prime would be 2 to the right and 1, 2, 3 down right here. Connect the dots and that's it, I'm done. Okay, number 2, for the sake of time, I'm going to skip it because it's pretty much, I already did examples like that. Okay, rotate it 90 degrees clockwise about the origin. So you would use the rule for the 90 degree. No, you know what? Let's go over it because I just realized it's asking us to go clockwise instead of counterclockwise, and I want to point out the difference in case you haven't realized it yet. All right? So look, if you look at this quickly, like I was about to do, it's easy to get confused and just imagine that said counterclockwise, which is to the left. But it does not. It says clockwise, which is to the right. Okay, so how am I going to do that? Okay, the way I'm going to do that, if it's multiple choice, you could just do it visually. But I'm going to show you how to do it and get the exact coordinates. You got to realize, let me draw a little picture here, that if I rotate, whatever, let me just draw that triangle, I don't know. If I rotate this 90 degrees, I don't know what I drew there, but if you rotate this 90 degrees clockwise to the right, that's the same as 270 counterclockwise. Okay? I'll say it again. Remember, a circle is 360. So if I rotate 90 degrees clockwise to the right, that is the same as rotating it 270 counterclockwise. How did I get 270? All I'm doing is mental math. I'm going in my head. 360 minus 90 degrees is 270 degrees. So 90 degrees clockwise is the same thing as 270 degrees let me try that again. 90 degrees clockwise is the same as 270 degrees counterclockwise. Okay, so why did I bother explaining that? Because the rules that we have are only for counterclockwise. So if I want to use those rules, I gotta translate this to how much it would be counterclockwise to use the rules. So I'm going to end up using the rule for a 270 degree counterclockwise rotation. Normally, I would not write the word counterclockwise. I'm just writing it in case there's anyone that's like, why is he doing 270? It says 90. Okay, anyways, so the rule is you get the x and the y, and they're going to switch places. And the x, you're going to change it to the opposite sign. And I'm kind of running out of space down here, but let me see if I can fit everything in. A, B, C. All right, so point A is at -1, +1. Point B is at -2, +3. And point C is at negative, did I make a mistake? Yeah, I did make a mistake, I'm sorry. B is at -3, +3. Sorry about that. -3, +3. B is at -3, +3. Okay, and C is at -2, +1, 2, 3, 4. So again, C is at -2, +4. Okay, so when I apply this rule, A prime is going to be at +1, +1. B prime is going to be, that says -3, +3, so it's going to become +3, +3. And C prime, that says -2, +4, it's going to become +4, +2. All I'm doing is switching the places of the x and the y, and when you put the x in the back, it's got to change to the opposite sign. So -1 became +1, -3 became +3, Negative 2 became positive 2. Now let me graph those points. So A prime is at positive 1, positive 1. B prime is at positive 3, positive 3. And C prime is at positive 4, positive 2. Now, I keep saying that you should be able to do most of them visually, but you may have some tricky ones where you do have to check the coordinates. So it is important to know this, okay? Because you may have to do it. You may have some that are tricky, where it's a little unclear what's the correct way it should look. And getting the coordinates is the only way to know for sure, 100%. Okay, so there you have a rotation 90 degrees clockwise. I got it by doing a rotation 270 degrees counterclockwise and using the rules. Okay, now I gotta reflect over the x-axis. That part's easy. So to reflect over the x-axis, A prime is 1 unit above the x-axis, so I'm gonna put A double prime 1 unit below. B prime is 3 units above, so I'm gonna put it 3 units below. And C prime is 2 units above, so I'm going to put it 2 units below. And that's it, I'm done. All right, there's my answer. Okay. Okay, on this problem, number 3, let's take a look. The answer is already here for us. And let's just examine it for one moment. And I'll show you how you could do a lot of these problems quickly by just choosing the right picture and getting the correct answer. Okay, so our starting point is triangle ABC right here. Now, they want us to first translate. The first thing that they want us to do is to translate triangle ABC by a vector of 4, 4. Okay, that means 4 units to the right and 4 units up. So if you take any one of these 3 points, let's look at point A, and move 4 units to the right and 4 units up, you can see that A prime is exactly there. I could have done the same thing with B to get to B prime and C to get to C prime. Alright, so right here, this is our first transformation. Okay, now the trickiest one is the second one, which says that they want you to do a rotate 90 degrees counterclockwise around A. Okay, so just to make sure we're all on the same page, they want you to rotate not around the origin, but around point A. Okay, now in a problem like this, you're not going to have to calculate the exact coordinates. So I'm going to show you how you could just figure it out just by looking at the picture. Because most likely you're going to have multiple choice question on this. So here's where I'm at right now. I'm on this triangle. So let's pick a side that we could focus on. For example, this side that goes from B prime to A prime. Okay, if I were to, the side looks something like that, right? If I were to do a 90-degree rotation of this side, B prime, A prime, I'm just drawing this blue line, I'm just drawing it here so that we can analyze it. If I rotate that line 90 degrees, it'll end up looking something like this. It's got to be perpendicular. Perpendicular. Okay, the B prime to the A prime would be here now if I rotate it 90 degrees. So look over here. That's exactly where B double prime to A double prime is. Except it's not, instead of being up here, it's all the way over here. So yeah, I could see how that could be a little confusing. But first, I'm just trying to show you that if you just focus on that line and you have multiple choice options, you could see how this one, okay, yeah, that looks about right for a 90-degree rotation in terms of how the entire shape would look. If you rotate this 90 degrees, let me draw it a different way. Okay, again, pretend this is where my starting point. Here's B prime, A prime. What I'm trying to say is if you rotate this triangle 90 degrees, this side right here will end up being like this, and the rest of the triangle would look like this. Alright, so this would have to be B double prime, A double prime, and the C double prime is over here. I didn't draw it perfectly, but that's pretty much how this triangle is. And again, if you have multiple choice answers, and you have 4 of them, Okay, there should be one that stands out. They're not going to be so close on a problem like this that you're going to have to calculate the coordinates. As long as you have a general idea of what a 90-degree counterclockwise rotation around point A should look like, that the triangle should end up looking like this and somewhere in this vicinity, that should be good enough to answer the question. And then our third and last transformation, they want you to reflect it over the y-axis. So if we're here, a reflection over the y-axis would give you this triangle over here. All the points are the same distance away from the y-axis, just on the other side. Let's look at number 4. Our starting point is this triangle. The answers are already here because for questions like this, I feel like for the sake of time, it's easier if we just look at the answer and analyze the answer. So we're starting off with this triangle right here, triangle ABC, which is in black. And our first transformation is to reflect triangle ABC over the x-axis. All right, so here's our x-axis. So you're just going to take all 3 points, and they have to be the same distance away from x, but on the other side of the x-axis. So since A is 2 units above it, we're going to put it 2 units below it to get A prime, etc. So here's our reflection over the x-axis. Our second transformation is to translate by a vector of -3, -1. All right, so that means the first number tells us we got to move the triangle 3 units to the left, and the second number tells us we got to move it 1 unit down. So if you just look at any point, let's look at B prime here. It's going 1, 2, 3 units to the left and 1 unit down, and you could verify that with any of the 3 points. All right, so there's our second transformation, and our last one is to rotate 180 degrees around the origin. Okay, rotate 180 degrees. When you rotate 180, it does not matter whether you go clockwise or counterclockwise, it's going to end up in the same spot. Okay, so 180 is a 180 degree rotation of this triangle is going to put it, I guess the best way to look at it is, let me draw something in the 4th quadrant here. If I rotate it this way, if I rotate it counterclockwise, a 90-degree rotation would put it something more or less, roughly, something like this, like B, C, A. Okay? So if I rotate it 90 degrees again, I want you to realize that the A is going to be pointing down, and the side with the B and the C has to be up here. If you could understand that, that's all you're going to need to know to answer questions like, most of the questions like this, because it's just a matter of picking the right multiple choice answer. Let's look at a few more and we'll be done. Okay, now here what I want to go over is just that fraction, which may cause some students to think this is going to be difficult. So let's look at it a second. Okay, this is the same thing we've been doing. The only thing is that the way they're writing the transformations is like this now. Instead of writing it out with words, they're just giving you the rules. Okay, so I'm going to walk you through this entire problem. All right, let's start with our pre-image of ABCD. All right, so the coordinates for ABCD, which is right here, here's ABCD. Okay, A is at 2, 2. B is at 2, 4. And C is at 6, 4. And D is at 4, 2. Now look, I'm going to try to get through as much of it as possible without letting the problem take me too long here. But just because I'm going to do a lot of work to show you how it's done doesn't mean you're going to have to do all the work that I'm going to show you, okay? I just want to make sure you understand how to do it. All right, so our first rule is telling us that you got to multiply the x and the y by 3 over 2. That's a dilation. Okay, now let me show you something. If I divide 3 by 2, you should know in your head what that is. But if you don't, 3 divided by 2 equals 1.5. So that means I'm multiplying both x and y by 1.5. If you multiply them by a number greater than 1, the shape is going to get bigger. And if you multiply them by a number less than 1, or a fraction less than 1, the shape is going to get smaller. Now, I know that may seem like common sense, but some people may not realize that. They may see that this is a fraction and just think, oh, it's a fraction, so it's going to get smaller. No, This fraction is an improper fraction because the numerator is bigger than the denominator. It's a number greater than 1. So that's why the shape is going to get bigger on our first transformation. It's a dilation that's making it bigger. Anyways, when I multiply the x and the y coordinates by 3 over 2, they're going to give you easy numbers that'll make it easy to get rid of the fraction. For example, if I multiply 3 over 2 by 2, the 2's cancel out, and that's going to equal 3. So a prime, the coordinates are going to be 3, 3. And we could verify, here's 3, a prime is right here at 3, 3. Okay, b prime, when I multiply 2 by 3 over 2, I just showed you that you get 3. And when you multiply 4, I'll do it over here. When I multiply 4 times 3 over 2, okay, turn 4 into a fraction. You know what? I'm sorry, let me keep it in the same order. 3 over 2 times 4. Okay, I put a 1 underneath the 4, so it's going to give me 3 times 4 is 12. On the bottom I get 2, and 12 divided by 2 is 6. Okay, over here, 6 times 3 over 2, or let me say 3 over 2 times 6. I put a 1 on the bottom of the 6. Obviously, if you're really good at multiplying, you should know that you could simplify this before you multiply it, and it's way quicker. For the sake of time, I'm doing it the longer way just so that everybody is with me, even the people that may not be too good with fractions. All right, so 3 times 6 is 18, and 2 times 1 is 2. And when I do 18 divided by 2, I get 9. All right, so this would be 9. And we already saw up here that 4 times 3 over 2 is 6. And the last one, we already did 4 times 3 over 2 gives you 6. And we already did 2 times 3 over 2 gives you 3. So those are my coordinates, and you could verify that. B prime is at 3, 6, which is right there. C prime is at 9, 6. And D prime is at 6, 3. Okay, so I did it correctly. Again, just knowing that you're multiplying it by 1.5, you can kind of figure this out if it's multiple choice without doing all this work. But just in case, I'm just showing you. Okay, now look, our next transformation is you're changing the x to the opposite sign. If you have your transformation rules memorized, when you change x to the opposite sign and leave y the same, you're doing a reflection over the y-axis. Because remember I said that when you reflect over the y-axis, all you do is change x to the opposite sign. So that's what this is. That's our second transformation. And our third transformation is right here. This is telling you, since you're adding 1 to the x, it's going to move the figure 1 unit to the right. And you're subtracting 2 from the y, so it's going to move the entire thing 2 units down. So as you could see, this entire quadrilateral is being moved 1 unit to the right and 2 units down. Again, on most of these, you're just going to be picking the right picture. And if I work out I tried to work out the complicated part, or the part that students find complicated. From there, you should be able to handle it, but you're most likely not going to have to do the work for all these coordinates on this assignment. Let's look at the answer here. Again, here it's telling us our transformations. Here's our starting point. Here's our first transformation, which is you're just multiplying the x coordinate by 3, and our last transformation. Let me talk about these a second. The first one, it's since you're only multiplying the x by 3, and the x coordinate controls the horizontal movement. Okay, that means it's going to be a horizontal stretch. Horizontal stretch, it's going to make it bigger horizontally by a factor of 3, because you're multiplying the x coordinate by 3. And then the second one, okay, you're multiplying both by 1/2. So it's a dilation by a factor of 1/2, but that negative sign in front of the y coordinate means you're reflecting over the x-axis. Okay, because, just a real quick explanation of that. Remember, the rule to reflect over the x-axis is to reflect over the x-axis, I gotta make the y the opposite sign. Okay, so that negative sign up here, that's what that means, that it's a reflection over the x-axis. The 1/2 and the 1/2 is, think about it as like two transformations in one. The 1/2 and the 1/2 is a dilation, and that negative sign is a reflection. So they're doing two things at once. So again, here's our starting point. When they multiplied it by 3, it was a horizontal stretch, which gave us A prime, B prime, C prime. If I needed to get the exact coordinates, I would multiply all the x coordinates by 3. The third transformation, I'm sorry, this is the first transformation and this is the second. The second transformation is two transformations at once. It's both a dilation by multiplying both the x and the y by 1/2 and a reflection as well, because they're putting a negative sign in front of y, a reflection over the x-axis. When you multiply the x and the y coordinates by these numbers, you're going to get our final result here, A double prime, B double prime, and C double prime. Okay, now in our next examples, we are going to have the same type of questions, except now they're writing out the transformations in this form right here. Okay, they're writing them out like this. So you could probably do most of them without getting the coordinates, but I'm going to do these examples getting the exact coordinates in case you do need them for a few problems or for the upcoming exam. Alright, so the way I would do it is like this. Alright, this is, I would think, the most efficient way to do it. I'm going to write the rule right here. And I'm going to write all the new coordinates underneath. And I know you may very well see some stuff like this in your intensive math class, because there are some IXL assignments that require you to do all this. Maybe not this much, but at least a couple transformations. Okay, so I'll start off with the coordinates for A, B, C, and D, our pre-image. Okay, so A, and I'll try to make it fast because I have a lot of work to do. A is at 2, 2. B is at 2, 4. C is at 6, 4. And D is at 4, 2. Okay, now, a lot of people get scared by fractions. Let me show you how simple it's going to be. In problems like this, for right now, because we're graphing, everything that they're going to give us is going to get rid of the fraction. They're going to be easy numbers to work with. I'll show you what I mean. Okay, like right here, I got to multiply 2 times 3 over 2, or 3 over 2 times 2. So I'll do it up here so you can see. 3 over 2 times 2. You turn the 2 into a fraction by putting a 1 on the bottom. Yes, you could simplify first, but I'm going to do it the long way, the slow way for all of them, just so that everybody, whether you're good at fractions or not, can get it easily, all right? So this is going to give me 3, and again, 2 times 3 over 2 over here will also give me 3. Okay, now B to B prime. We just saw that 2 times 3 over 2 gives me 3, so I could just put the same number. And 4 times 3 over 2. If I multiply 3 over 2 times 4, make the 4 a fraction by putting a 1 on the bottom. So I multiply the numerator times the numerator, and the denominator times the denominator. And 12 divided by 2 is 6. So I got a 6 here. Okay, now C to C prime. We already know that 6, I'm sorry, no, I do got to multiply 6 times 3 over 2. So 3 over 2 times 6, I turn the 6 into a fraction. That's going to give me 18 over 2, which equals 9. Alright, so 6 times 3 over 2 is 9, and 4 times 3 over 2, we already did it over here. It's going to give you 6. And this one, we've already done it. So 4 times 3 over 2, we did it here. It gives you 6. And 2 times 3 over 2, I already did it up here. It gives you 3. Alright, so those are my coordinates. And if you check, they all work out. A prime is at 3, 3. B prime is at 3, 6, which is right here. C prime is at 9, 6, which is right here. And D prime is at 6, 3. One thing I want to point out is this. since they multiplied both sides by both coordinates by 3 over 2, what's 3 over 2? Some of you know this easily, but some of you, I'm not sure if you realize it. 3 divided by 2 is 1.5. Everybody should know that. So if we're multiplying x and the y coordinate by a number bigger than 1, the shape will always get bigger. And if you multiply by a number smaller than 1 but greater than 0, it'll get smaller. Okay, I'll say that again. If you multiply by a number bigger than 1, the shape gets bigger. If you multiply it by a number that's between 0 and 1, it gets smaller. Okay, so in this case, the shape got bigger. It's a dilation by a factor of 3 over 2 or 1.5. Okay, now the second transformation that we're doing is we're just changing all the x coordinates to the opposite sign. If you have your rules memorized, that means it's a reflection over the y-axis. Because I said that when you reflect over the y-axis, all you got to do is change the other letter, the x, to the opposite sign. Okay, so a double prime, I'm just going to change all the x coordinates to their opposite sign so that you guys could see. Again, you're most likely going to be able to answer the questions without doing all this work. However, in case you encounter something like this, I want to cover it so that you have an idea how to do it and you could see that it's not, it is a little bit, it takes some time, but it's not impossible or anything. Just one step at a time. That did not come out right. That's supposed to be a 6. Let me just scratch that out and write it again. It's supposed to be -6, +3. Okay. And believe it or not, just one more transformation to go. Okay, now this one, let me do it up here. You should realize that just means since you're adding 1 to the x, it's going to move the entire figure to the right 1 unit. And since you're subtracting 2 from the y coordinate, it's going to move the entire figure down 2 coordinates. So to the right 1 and down 2. So if I got multiple choice answers, I could easily see, that to do that, it's going from this quadrilateral to this one. Okay? And it's a little hard. You got to look carefully because it may be easy to confuse where those letters are. But if you look, the B double prime and the C double prime, all the ones that have double prime, it's like a lighter shade of gray. Whereas this one down here is darker. The colors are darker. And it's B triple prime, A triple prime, D triple prime. So that you realize that there's a difference. It may be hard to tell at first glance, but there's a difference. Anyway, so let me do this last transformation. So for A triple prime, it gets difficult to write when I'm at the bottom here. A triple prime, I got to add 1 to all the x coordinates. So -3 plus 1 is -2. And I got to subtract 2 from all the y coordinates. 3 minus 2 is 1. And again, by writing the rule up here, I could just look and do it easily and catch any mistakes easily as well. So B triple prime, I'm having a hard time writing it down here. B triple prime is -3 plus 1 is -2. And 6 minus 2 is 4. C triple prime is going to be -9 plus 1 is -8. And 6 minus 2 is 4. D, for D double prime to go to D triple prime, I'm going to do -6 plus 1, which gives me -5. And 3 minus 2, which is 1. Okay, and if you check, A triple prime is at -2, +1. B triple prime is at -2, +4. It all checks out, okay? All my coordinates are correct. Again, are you going to have to do all that work? Most likely no. But just in case, let's look at another example here. For this one, I'm just going to show the answer. I am going to do another example where I work it out, but for this one, let's just look at it a second. Okay, so our first transformation is you're multiplying all the x coordinates by 3. That's why, since you're only multiplying the x coordinate, and the x coordinate controls the horizontal movement, the first transformation is a horizontal stretch by a factor of 3 because you multiplied by 3. Okay, and that's the one that's labeled A prime, B prime, C prime. That's this one. It's a horizontal stretch, and it also affected the position of a lot of these points. Okay, then the second one is a combination of two things. They're multiplying the x and the y by 1/2, Okay, so it's a dilation by a factor of 1/2. Notice that the negative sign is not written here. They just wrote by what number you multiplied it by, which is 1/2. What the negative sign does is do a reflection. Okay, so it's a dilation combined with a reflection. The negative sign means the negative sign in front of the y coordinate means it's a reflection over the x-axis. Okay, let's look at an example where I'll work out the whole thing. I'll say that one more time, by the way, because I could see how that might sound confusing. Let me show you how I figured that out. If you, sorry, having technical issues here. All right, there we go. Okay, if you remember, if the thing is, if you have the rules memorized, okay, when you reflect over the x-axis, I said that to reflect over the x-axis, you got to change the y to its opposite. That's what's happening here. The thing is, they're adding a dilation as well. So this transformation right here is like two transformations together. It's a dilation, that's what the 1/2 is, as well as a reflection. That's what the negative sign is. So you got to realize that it's like two things in one right here. This they could have written it out as two separate steps, but they put it all together, the dilation along with the reflection with this negative sign, okay? So it's basically like three transformations in total. Here's the first one, and then the last two are here written together, a dilation as well as a reflection. All right, I'll do this question and one more where I read out all the coordinates because they're time consuming, but just in case you guys need it for the homework. All right, so again, the first thing, and again, you may very well encounter this in your intensive math class with an IXL assignment or two. All right, so on the top, I'm going to write the rule. And then underneath it, I'm going to write all the coordinates. And I'll try to do it as quickly as I can because it could take long if you go slow. Okay, so first I'm going to write my pre-image, A, B, and C. The coordinates for A is 2, 2. For B is 2, 5. For C, it's 3, 2. I highly recommend that you copy my method. If you ever have to do this, copy my technique of writing the rule and writing it this way. It'll stay organized and you won't mess up. And if you do mess up, it'll be quick. It'll be easy to catch the problem quickly. Okay, so first thing I got to do is subtract 1 from the x coordinate as well as the y coordinate. All right, so this is going to become 1, 1. B prime is going to become 1, 4. C prime is going to become 2, 1. I got to move quickly. No mercy. Let's go. All right, A double prime, B double prime, C double prime. Now I got to multiply all the x coordinates by 3. All right, so this is fast. And the y coordinate stays the same. Okay, 3, 4, and 6, 1. Look at that, we're almost done. And the last one is going to be A triple prime. Whenever I get to the edges, it gets difficult to write on the tablet I'm using, so sorry if it gets a little sloppy. Okay, so now I just got to change them both coordinates to their opposite sign. Okay, so how long did that take me? A minute? 2 minutes? Okay, it's really not as complicated as it looks. Even though you see a lot of stuff written there and it may look complicated, but it's really not. And then let me graph all these points real quick. Okay, so A prime is at 1, 1. All right, A prime is at 1, 1. B prime is at 1, 4. Wait, 1, 4. I almost messed up. And C prime is at 2, 1. Alright, so that's my first transformation. If you're picking from multiple choice pictures, you should realize that this is telling you to move the shape 1 unit to the left and 1 unit down, which is exactly what we did. Okay, now the next one is should be a horizontal stretch because we're multiplying only the x coordinate by 3. Alright, so let me plot those points. A double prime is at 3, 1. This is going to get, you know what, let me use a different color because they're too close to each other. Let me try blue. And I was going to say it's about to get a little messy because everything's too close together. But what choice do I have? So 3 comma 1, and that's going to be A double prime. Okay, B double prime is at 3 comma 4. And C double prime is at 6 positive 1. So that one's in blue. Whoops. Alright, something like that. I know I didn't draw it perfectly. It's hard with the tablet I'm using. Okay, and then let me try, I don't know. I usually pick this color because it's easy to see and the other colors are not. But okay, so that's the second transformation. The last transformation, okay, when X and the Y stay in the same place and you change their signs, that's a 180-degree rotation. So let me plot the points. A triple prime is at -3, -1. A triple prime. Okay, B triple prime is at -3, -4. And C triple prime is at -6, -1. Okay, and that's my final spot. And I'll show you the answer from the book now, which will be uploaded with the PowerPoint to Microsoft Teams, and it should look exactly like what I drew there, or pretty close to it. And there, as you can see, it is. For the sake of time, let me skip this one and do this one, okay? So look, there's one that I'm just going to leave the example in there if you want to look at the video, but I'm not for the sake of time because this lesson is taking a long time. Let me just do this last one just because it has a bunch of fractions, okay? So you could see that it's not impossible. It's not as difficult as it may look. All right, so let me do this one here. Again, on the top, first thing I'm going to do is write the rule, and I'll write everything else underneath it. Let me try to write it small if I can. This is, let me write that better. -3/2y. If you can't understand what I wrote there, just look right here. It did come out sloppy, but like I said, with the tablet I'm using, it gets difficult when you get near the edges to write. Okay, and then let me draw a little line to divide the rule from the coordinates that I'm going to write underneath it. Let me change my pen color to make it easier to follow what I'm doing. Okay, so first thing I'm going to do is write A, B, C. Let me give myself plenty of space because there's a lot to write. A is located at 4, 0. B, and let's see how quickly I could do this and accurately. Okay, B is at 0, 9. And C is located at 6, 3. Okay, so there's my arrows. Okay, now look, the 3/2 and the 2/3, let me multiply them, I don't know, somewhere over here. Okay, so I got to do, the first one is -3/2 times 4. Let me just write 3/2 times 4. Ignore the negative sign for 1 second here. 3/2 times 4, okay, is going to give me 12/2, which gives me 6. And a positive times a negative equals a negative. So this gives me -6. Okay, and the other one says 2/3. 2/3 times y is 0. Anything times 0 is 0. Okay, by the way, notice it has fractions, but with the numbers that they're giving us, when you multiply, you don't get a fraction. So it's not as difficult as it may seem. Okay, let's do the next one. 0 times anything is 0. Oh, I'm sorry, I forgot to write A prime here. Let me write that. A prime. B prime. 0 times anything is 0. Now I got to do 9 times 2/3. Or 2/3 times 9. Let me write it down here. 2/3 times 9. Put a 1 beneath the 9. On the top, you're going to get 18. On the bottom, you're going to get 3. 18 divided by 3 is 6. And they're both positive, so my answer is positive. And then over here for C prime, okay, so I got to do 3 over 2 times 6. Ignore the negative sign for 1 second. 3 over 2 times 6, put a 1 beneath the 6. That's going to give you 18 over 2, which is going to give you 9. And a positive number times a negative number equals a negative number. So I got negative 9. And 3 times 2 over 3, the 3's cancel out and you're going to get 2. Okay, the 3's cancel out and you get 2. For the sake of time, I'm trying to, save a few steps there. Okay, then let me do the next one, which would be A double prime, B double prime, and C double prime. Alright, so all the x coordinates, add 6 to it. Negative 6 plus 6 is 0. All the y coordinates, subtract 4. 0 minus 4 is negative 4. Alright, over here, 0 plus 6 is 6, and 6 minus 4 is 2. And over here, negative 9 plus 6 is negative 3, and positive 2 minus 4 is negative 2. Almost there. Defeat does not exist in this dojo. Alright, now I'm going to multiply 2 over 3 times whatever x is. X is 0. 0 times anything is 0. Okay, negative 4 times negative 3 over 2. Alright, a negative times a negative equals a positive. And 3 over 2 times 4, actually I already did it over here. 3 over 2 times 4 is 6. And we said, what did we say? A negative number times this negative number is a positive number. So it's going to give me positive 6. Okay, and that's, again, I forgot to write the letter, A triple prime. Okay, the last one is, or B triple prime. Okay, 6 times 2 over 3. Did I do that already? Yeah, I did. No, I didn't. My bad. Okay, so 6 times 2 over 3, or 2 over 3 times 6, is going to give you 12 over 3, which equals 4. Okay, so 6 times 2 over 3 gave me 4. And 2 times negative 3 over 2. The 2's cancel out, and you get negative 3. Okay, and last one, C triple prime. Negative 3 times 2 over 3. A positive number times a negative number equals a negative number. The 3's cancel out, and you get just 2. Over here, negative 2 times negative 3 over 2. A negative number times that negative number gives you a positive number. The 2's are going to cancel out, and you're just going to be left with positive 3. Okay, those are my coordinates. For the sake of time, I'm going to go to the next slide, which has the graph. But there are the coordinates. I'm just going to show you the correct graph of what I just did here. Okay, yes, it's a little bit of work. Okay, but really, it gets messy. It's a little bit of work. But what did it take me? Like 2 minutes? The only people that are going to struggle are if you're not too good at fractions, and that's something that is going to keep coming up throughout the whole year. The sooner you master it, the better for you. And the only way to master it is by doing it a lot of times, repeating it, okay? So, okay, we're almost done. Here's a type of question that you're going to have, and I want to go over how you do it. It's not difficult, but some students may get confused by it, so please look at how you do this. I already have the answers here because it makes it easier to analyze. Let's look at the first one. It says B, okay, figure B, which is this one right here, is the result of the following sequence, okay, of the sequence G reflected over a vertical line. So they're saying this figure B is the same as if you were to get figure G, which is this one, reflected over a vertical line and then a horizontal line. All right, so let's look at that. Okay, let me draw it down here so you could see what they're saying in case you don't follow. All right, G looks like this. All right, now just for the sake of making it easier to look at, let's pretend it's a shark looking to the left. It's a shark looking to the left. Okay, now if I take that shark and reflect it over a vertical line, now the shark is going to be looking to the right. Okay, and then if I reflect it again over a horizontal line, this is a horizontal line. If I reflect it again, now the shark is going to be upside down, looking to the right. And if you look, again, I started with G, and the final result is what figure B looks like. Alright, that's why B is the answer for this one. Okay, let's look at the next one. Let's look at number 10. Okay, number 10 says E is the result of this sequence. First of all, let's locate E. E is this one right here. Okay, again, let's think about it like a shark. Here's E, shark E. It says it's the result of the sequence of D. Alright, if you start with figure D, which is this one right here, and rotate it 90 degrees clockwise. Alright, so let's look at that. Alright, I'm gonna draw D over here just so that I could talk about it. Here's D. And just for the sake of helping us picture this, let's pretend again that it's a shark, or whatever you want to call this little animal that I drew here. These are the ears or the fin of the shark. What depends on what animal you see. But it's looking down. If I rotate it 90 degrees clockwise, clockwise is like this to the right. This is clockwise. So if I rotate it 90 degrees, okay, this line right here, sorry, having a hard trouble drawing that. Alright, this line right here is going to end up like this if I rotate it 90 degrees. That's the bottom of the shark or the animal or whatever. So it's going to be like this now if I rotate it 90 degrees clockwise. Then it says, by the way, it says 90 degrees clockwise around one of its vertices. Okay, it could have been any of these points, but listen, they're talking about this one. It's only going to be this one. So 90 degrees clockwise around this vertex. Okay, now, and then reflect it over a horizontal line. Okay, so here's a horizontal line. If I reflect it over that, it's going to be like this. Okay, and that's what E looks like. That's the direction that E is in. Okay, these questions are going to be multiple choice. It's just a matter of looking at the sequence and seeing when you do that sequence, how do you get one of those choices. I mentioned that it's going to be multiple choice because you may look at E and G and they're both the same thing. But when you get to that on the homework assignment, you're not going to have two answers that look exactly alike, okay? So it's not going to be, it should be, if you understood what I just did, they should be easy to answer. Okay, and the last types of questions that I put are, okay, let me explain. It's not, I know you see a lot of words there, but basically it's going to be transformations like what I've been doing throughout the majority of this lesson, but it's going to be walking you through each step of the transformation and you fill in the blank saying what's going to happen when you do that transformation. Okay, I'm not going to go over these, but I'm including them in case you need to see them later in the video or in the PowerPoint that I'll upload to Microsoft Teams. On the video, you could always pause them and look at these answers. But again, it's the same transformations I've been doing throughout all the examples, but they'll walk you step by step and ask you to explain what's happening when you do this. It'll be multiple choice, so it should be easy to answer. And with that, that concludes today's lesson. Your homework is going to be in the student portal as always, and it's due by 6 a.m. of the following day that you have my class, or before 6 a.m. of the following day that you have my class.